DT graph is a graph in physics that plots d versus t. This d could be either distance or displacement. Sometimes we even call them PT graphs because we're referring to position. In any case, it's always meters that's being plotted versus t, which is time. Normally, I just refer to them as distance-time graphs. But know that I mean displacement or position. A DT graph plots d on the y-axis and t on the x-axis. So here's a DT graph. The slope of a DT graph tells you the velocity of the object being graphed, or the speed. You can memorize this fact, or you can notice that the slope of the graph is y over x, which is meters, over seconds is meters per second, which is the unit of speed. So if you're ever confused and you forget, look at the units. They'll tell you what the slope will give. A VT graph plots velocity or speed versus time. This is meters per second versus time in seconds. Time is always the variable on the x-axis in physics. So a VT graph, which is meters per second and seconds, looks something like this. And the slope of a VT graph, instead of giving you v, the slope gives you v over t, which is acceleration. This can be remembered as well by looking at the units. Slope is always y over x, and a meter per second divided by a second is a meter over second squared, is a meter per second squared, which is the unit of acceleration. The slope of a VT graph is acceleration. So the slope of a DT graph gives v in meters per second. The slope of a VT graph gives a in meters per second squared. Here's an example of a DT graph to help you understand how to analyze a situation by looking at a graph. This graph has many sections on it, and I'm going to analyze each section so you understand what's going on. Remember, the slope of a DT graph is equal to the speed, or the velocity. This is because this is distance in meters and time in seconds, and a meter divided by second is a meter per second, which is speed. Looking at the first section is flat. A flat line has a slope of 0. There are several other sections like this on this graph. Anytime the slope is 0, the speed is 0 as well. A speed of 0 means not moving. So if you ever see a flat line on a graph, a flat line means not moving. The next section here has a negative slope. It's sloping downward. This tells us that the v, whatever the number is going to be negative. Negative speed means backwards, or down, or south, or left, or west. The next section along has a slope that's positive. It's sloping upwards. This means v, whatever number it gets, is going to have a sign that's positive, which means this velocity or speed is going to be forward. The last section of the graph is curved. A curved graph has changing slope. If the slope is changing, therefore we have changing v. Changing speed or velocity means acceleration. So a curved line on a dt graph is acceleration. And you can tell whether it's getting faster or slower by what's going on. Since it's getting steeper and steeper, the value of the velocity is getting bigger and bigger. So this one is speeding up. To summarize, flat on a dt graph means not moving. Sloped down means backwards. Sloped up means forward. Velocity, backwards velocity. And curved means acceleration. We're going to look at a similar kind of situation on a VT graph. On a VT graph, the shapes mean different things. A VT graph is meters per second, which means the slope of a VT graph is equal to the acceleration, which is meters per second squared. Meters per second means meters per second squared. Here's my graph. So there's some shapes on this graph too. We have flat lines, slope down, sloped up. Whenever you encounter a flat line, this is still a line that has a slope of 0. Whenever we have a slope of 0, we have acceleration of 0, which means it's not accelerating if it's flat. Or we have what we call constant speed. If we look at this line here, this is a special case of acceleration equals 0. The velocity at this line is all the way down at the bottom, at the 0 line. This is any time the velocity dips to 0 and stays flat. This is what not moving looks like. It's still constant velocity, but it's constantly not moving velocity. Slope down is negative slope, so we have an acceleration that's negative. In this case, we have a positive v. You can tell because all these velocities are in the positive quadrant of a graph. So positive v and negative a means slowing down. And the last section is sloped up, which is positive. That gives us an acceleration that's positive, and it's speeding up. So to summarize, on a VT graph, a flat line means constant velocity. Flat line at 0 equals not moving, which is still constant velocity. It's still a flat line. It's just not moving with a velocity of 0. A sloped line means acceleration. And most of the time, negative means slowing, positive means speeding up.